Okay, on today's episode of the On.NET Show, we're here with Cesar. We're going to be talking about Microservices Architecture with ASP.NET Core. You'll definitely want to check it out. Welcome to another episode of the On.NET Show. Today we're going to be talking about microservices and architectural patterns with Cesar de la Torre.
Right.
Yeah, so how about you quickly introduce yourself and then we'll get into the topic.
Yeah, so I work as PM in the .NET team.
Yeah.
And my focus is most of all about .NET application architecture, guidance, reference applications, and provide that through ebooks, technical ebooks, and those applications, and also in these kind of events.
Yeah, and we're teammates, right? I think we've worked together for what, 6 or 7 years or something like that? Longer?
In here?
Yes, at Microsoft.
Yeah, well, Microsoft, it's been 11 years.
Oh, okay.
But in DevDiv, it's going to be 6 years almost.
Yeah, exactly. Yeah, so how about you tell me about this the site that you have up right now? I think this is kind of the homepage for your architectural guidance.
That's right. Yeah, so we've been working on this for quite some time.
Yeah.
It's not just about microservices, so we created a site about .NET application architecture. As you can see here, there are multiple areas about mobile applications, Windows apps, regular web applications, but modern with ASP.NET Core, the cloud with Azure, how to modernize with Windows containers, your existing apps. And this is the area that we are focusing today, which is about microservices architecture and Docker containers. So if you go to the Microsoft .NET side, then you click on the architecture link, you'll get here, and this is the area that we're going to be talking about. So we have a very extensive book about microservices that I wrote, and then a reference application and videos and so on. So for instance, the book is, you can download it for free. It's deep content about microservices, like around 300 pages. So the first section is about architecture patterns, and so you could read like the first 70 pages just to know about what is that. And then the rest of the book is about the implementation with .NET Core. So depending on how deep you want to go. But the cool thing is that it's not just this content, it's also related to reference application that we have in GitHub. So it's called eShop on Containers. It's an eShop because we just wanted to find like a very well-known domain for developers. We're not trying to create a reference about e-commerce. This is just about to learn microservices and Docker containers. But you can see it's been pretty successful. We have like 2,000 forks, almost 6,000 stars, a lot of people watching it, and then here you can see that you can run this kind of in 2 levels. If you are just trying containers, you can run everything in your laptop like here, just with Visual Studio or even the CLI and just Docker for Windows, and everything will run. All the containers will deploy like I have it now here in Visual Studio, and then all the containers, like if I do Docker PS, you see all the microservices and containers running locally, and even the infrastructure is being deployed automatically. So we're deploying a SQL container, a Redis container, RabbitMQ for event bus, everything, even MongoDB, everything running locally, and you just need to hit F5 in Visual Studio, and everything will get downloaded, all the images pull down, and everything will run. That's kind of the first step, but then you can also move ahead, and if you're thinking about a production environment, then you can swap things, like for instance, instead of a SQL container, you will move to a SQL database in Azure, or instead of a MongoDB container, you move to, not DocumentDB, Cosmos DB now. Instead of RabbitMQ for messaging, you use Service Bus and so on, Redis cache and so on. So we have all that in place, all the code ready. You just need to put your secrets, your keys. And instead of deploying on a regular Docker container, you would deploy in a scalable orchestrator, either AKS with Kubernetes or Service Fabric as well. That's kind of the summary. And here you can see the architecture where we have 3 client apps. We have a Xamarin app, a regular MVC application, Angular single-page application, and then multiple microservices, all of them autonomous, independent, with their own data, API gateways, and so on.
Right. So if I take this application, kind of get familiar with it on my machine, potentially make some changes to it just to kind of get a sense of what it means to make changes in multiple kind of parts of the architecture. Once I get there, then it's, and say I have an Azure subscription already. What I'm hearing is it's relatively straightforward to go and deploy that to Azure and then actually have that, at some point I'd put an SSL certificate somewhere and it would just appear like a real application in the cloud.
Yeah, first of all, you don't need Azure in order just to test it in your PC. But then you can move to Azure and do it pretty easily. It's not just the code. We also create here in the wiki all the procedures on how to set this up with Visual Studio or even with a Mac and CLI, or how to deploy this in AKS or Service Fabric, and all the details that you need to do step by step.
Wow, looks like a lot of content. Now, can you tell me about the type of what kind of customers do you talk to who you believe are using this content? Is there any kind of clustering there?
Yeah, it could be any industry, but microservices is not kind of the silver bullet, so it's not for any kind of application. So more than any type of customer, could be enterprise customers, could be ISVs, but most of all, we're talking about large applications, and that also need to evolve in the long term, and potentially or probably in each area, like one area per microservice, you want to evolve that independently. Like you have one development team for this area, another development team for this other area. And then not just to deploy that independently or work on that autonomously, because you deploy your microservice, you deploy your database related to that, and it shouldn't impact as much as when you have a monolithic application.
Right. So here I'll ask you the hard question. What does testing look like in this kind of model? Do you have fairly focused unit tests for each one of these systems and call it good? I assume not. What does the testing strategy look like?
So we basically have kind of 3 levels of testing. One would be unit tests per microservice. And then we have integration tests. So that would be taking into account data and other things that are not just your code. And finally, what we're calling functional tests, and that would be taking into account the whole system. So let's say I create an order from the UI that is coming through the API gateway, and then this is calling to 1 or 2 microservices, and that whole execution would be a functional test. And for that, you need to have the whole application either in Docker, a Docker host, or in the orchestrator.
Sorry, what did you mean by that last part? You say you need the application in the Docker host or in the Docker orchestrator?
Or in the Kubernetes.
I see. Right.
Yeah, because it's not like just running unit tests with your code. You need the actual microservices or containers to be up and running somewhere, and then you run the tests, the integration tests or the,
Makes sense. And you didn't say this, but tell me which technologies you used here. I assume you used, a bunch of ASP.NET Core here and there and some Xamarin. Can you talk to that a little bit?
Well, from the client side, the mobile application is Xamarin Forms, so it can run on Android and iOS. And then the web applications, the single-page application is Angular, but then in the server side, it's MVC, and the same thing for the regular or traditional web application. It's MVC, but all .NET code here is .NET Core. So it's cross-platform. Usually, by default, we are deploying into a Linux Docker host. You can also run it on a Windows Docker host. and then usually we deploy it into Kubernetes, also in Linux.
Right.
And then about the microservices, all these microservices are ASP.NET Core web APIs, and then the API gateway, it's based on Ocelot, which is an open source project, especially made for API gateways. But at the end of the day, you have like a NuGet package, and then you host that into a web host, ASP.NET Core as well.
Right. Now, to remind us, what is so I think most people will understand what an API-based microservice is and means. What additional value does a gateway provide on top of those? Because I think the applications are just touching the gateway. They're not actually touching the services themselves.
Yeah, that's right. So think about, in this case, this is a kind of small, medium microservice-based application, and we have like 1, 2, 3, 4, 7, 8, 9 microservice types. But even with 10 microservices, if you have to access those microservices directly from the client apps, you will need all those URLs from the client. But it's not just about the number of URLs, it's also about even about security. So you want to surface only the APIs that the client applications need, not the rest. So potentially you might have quite a few microservices and internal APIs that shouldn't be called directly from the outside. So basically the API gateway is like a front-end facade for your microservices. So you are simplifying that front end of services to be consumed by the client apps.
No, oh, sorry, go ahead.
Yeah, and something else that I want to say is, that's one thing, but then something that I'm highlighting in the guidance is the fact that might not be good to have a single API gateway, because then you could be kind of breaking the autonomy of those microservices. Like if you are deploying autonomously this microservice, but then every time you do something here, you need to change something in a monolithic API gateway, then that kind of API gateway is becoming the monolithic thing, right?
Yeah.
So that's why a good pattern is to have multiple API gateways. Could be larger or smaller. One pivot would be what you see here. BFF is backend for front end.
Yeah, I've
so
seen
you can
that term before.
create kind of a special API for the mobile apps, as you can see here. These two are specially made for the mobile applications, and these two are especially made for the web apps, because you might need different API when you are talking from the mobile app or the web application, right?
Yeah.
And then the same thing could be about areas, like business or domain areas. So this is about the shopping area or the marketing area. In this case, because this is a small sample, we just have 2 domains or areas, but you could have more.
Right. Now, I could imagine a situation where you build up these facades, which are these gateways, and there's kind of this, I assume maybe there's this tension between wanting to kind of aggregate functionality, which seems like it could be a good thing, but then also maybe the gateway could get a little bit on the fat side and almost become a service on its own. Can you speak to that?
Yeah, that's a good point, because in this diagram, this is simplified, and you can see just kind of the API gateway, which at the end of the day, an API gateway is like a reverse proxy with a single URL, and then you are redirecting to or routing to different internal endpoints, right? But then there's another, well, you could have also cache or authentication, quite a few things in the API gateway, but the most important thing is reverse proxy. But then the other thing is aggregation.
Yeah, that's where I was headed.
So the aggregation, so the less you put about logic or these kind of things in the API gateways, the better. It should be as thin as possible. But sometimes it's important to have an aggregation here, for instance, and especially for the mobile applications or even the single page application, which is remote. If it is the MVC application, which is, you can see here, it's running within the same orchestrator, same cluster, because of the latency is smaller. Well, if I do a few calls here, like 2 or 3 microservices, it's okay.
Yeah.
But if you are talking to the server side from the mobile app or from the browser in the single page application, and let's say you are loading a single screen or page, and you need to talk to 3 or 4 different microservices, that would mean 3 or 4 HTTP requests, and that's not going to be very optimal.
Well, and also, I would imagine in many cases they can't be made parallel because you're actually using the output of one call to make the other one, so they have to be sequential.
So that's why if you see this other diagram, which is a little bit more detailed that I have here in a deck, where is it? Well, I'm not sure if I have it here now. Well, maybe here you can see it. No, I don't have it here, but in any case, what we also have is like in the case of the shopping area, because we need to talk to a few microservices here, we have an aggregator container or API that for just some cases, you do a call from the mobile application, for instance, and then this one is talking to 2 or 3 microservices and responding just a single time. So that is optimizing. So it's not so chatty.
Makes sense. Okay, so it sounds like if people are really interested in this, they can go to the website, they can read the books. That's probably good for the type of person that really just wants to build up a mental model of what this whole space looks like, and then they can kind of talk about it with some level of kind of authority and context. And then we also have these GitHub repos for people who want to kind of really dig in, experience it through Visual Studio, step into code and potentially even deploy it somewhere to figure out what that looks like. I guess, do you have any advice for someone who's going to go do that?
I would like to. You mean about architecture or about
adopting these samples to make the most out of them?
Yeah, I can talk about 2 things. One would be about how to adopt the samples or even the microservice architecture, and then the other thing that we can talk about maybe a little bit of patterns or anti-patterns in microservices.
Okay.
That's the other thing I want to talk about. So first thing on how to adopt this approach, we really recommend not to start from scratch and trying to do everything right the first time. So probably it's better to start with something which is even monolithic, where you are putting the logic and the business domain that and then you start splitting that into smaller pieces. But thinking about also that, and this is the most important thing about microservices, that each microservice has to own its own data. So, and that's one of the most challenging things in microservices. So you shouldn't have just a single database or just a couple of databases and then a bunch of services, because then it's going to be monolithic because of the data, and instead of a process, you will have multiple processes, but that is not what microservices mean.
Yeah, it also makes validation, like your risk level goes up quite a bit when you deploy a change and the data side of it is being used by three things.
And then it's not going to be true that you have autonomous deployment, because then it will be impacting the database, right? So in regards to adoption, you can start with something which is monolithic and then start splitting it, or even adding new features as microservices. But each microservice with a new, with its own data owned by it. Like you can see here, small database per microservice in the diagram. That's one thing. Another thing is, if you use the API gateway pattern, that's an advantage for that, because from the client perspective, you wouldn't know what you have inside. If you have like 100 microservices or just a monolithic web API plus other small microservices, and little by little, you can evolve and split up that monolithic API in other microservices. But from the client side, you wouldn't notice while you are refactoring that.
Yeah, right? I think I first read there was a blog post that I think Netflix put out, I want to say like 4 years ago or something like that. And I think that's where I first saw that BFF term, and I think that was the approach that they took, was to build
back
up,
end for front end.
build out that gateway first, replat the clients on top of that gateway.
Yeah.
And then you have the separation you need, and then you kind of never have to talk to the clients again, and then you do your architectural thing.
Right, like you're kind of decoupling
Your
your
decoupled.
microservices from the client, and then you can play with that, right?
Yeah.
That's one thing. The other thing, to me, is the most important. Like each microservice has to own its data. Okay, that's one thing. But the other thing is, and this is a kind of an anti-pattern that I've seen from many developers or companies, is that they start using microservices like if they were objects, and they start kind of you talk to or you do a request to one microservice, and this one is talking to another one, and this one to another one, kind of long chains of HTTP, and that is really bad because at the beginning it's going to work, but then it's going to be in reality what you are kind of building is like a monolithic, a distributed monolithic, right? And the issue here is that if you start with having issues with one microservice, or it's going slowly, then it's going to impact exponentially the whole thing.
It's just a pile of spaghetti.
Yeah. So, yeah, I have one slide here which is pretty, and this is why it is also important to. Where do I have this? Yeah. So this is what you shouldn't do. Like you have the client app, it's talking to from the API gateway for, let's say, to a basket microservice, this one to another one, and then responding. But then if that microservice is failing, then or going slowly, and think about thousands of HTTP requests like that, it's going to be pretty bad. Or even if you were using retries, because sometimes you have like a very small problem with the network, and these microservices start giving a problem, then all the microservices are going to start retrying, and then you can cause like a denial of service to yourself. Right? So the important thing is to really isolate or identify autonomous boundaries. So each microservice should be pretty independent from other microservices, and then if you need, because sometimes you might have like kind of the same entity in multiple microservices data. Right. So that's the challenge.
Right. So I mean, one of the things I find with a lot of the work that we do, and it applies here too, is there's this modeling challenge. Like you have to spend a bunch of time on modeling and have a set of characteristics in your mind that you want to apply to the software you built, and your model is the thing that kind of has to account for all of that.
Yeah. So thinking about the models and how to split the big model into multiple models is probably the most important thing. Like bounding context, which is the name that you use in domain-driven design, which is pretty similar.
Yeah.
And then maybe one entity could be even the same entity split up in multiple pieces. But maybe in the catalog, I have all the attributes for that entity of the product. But maybe in the basket, I just need the ID and maybe the price, but not the rest, right? So, but then if you see here, the call, when I talk to from the client with HTTP, it would be just to the first level. So if something happens in any internal microservice, you just send an event, and you send that communication to other microservices through an event bus or service bus or RabbitMQ. So basically, this is to have eventual consistency between those small models.
Yeah, that's a super important word.
That's the most important thing here, because maybe when I change the price in the catalog for a product, I want to be aware about that in the basket. But I will keep the price in the basket, and the new price is going to come with an event asynchronously. So finally, what you get is that from the client, you're just when all that propagation of data and eventual consistency is done, from the client, you just need to talk to one microservice, and maybe something happens again. But it's like the client app or the API gateway should talk just to, as much as possible, to a single level of microservices, not a long HTTP request.
Yeah, I almost see it as, and then we should kind of finish up, is this kind of approach is almost like client-first development, meaning your architecture is oriented on the best possible experience for your client. Whereas the very first diagram is almost like a back-end first. Not that it's great for the back-end, but a back-end first approach, which is it's oriented on consistency now, whatever the opposite of eventual consistency is. So it's kind of on the easiest way for the back end, but the client suffers a lot. So on the second diagram, the back end has to kind of use these other techniques to cause data to flow in various ways.
That's right. And this is where, if we come back to the architecture, you see that we have an event bus, which is running on top of RabbitMQ or service bus, and we use that for this eventual consistency.
That's kind of your backplane of sorts. Yeah. Okay, is there anything else you want to just say in closing?
No, just that, well, it's not just running this locally. You can also deploy this, as you can see here, in Azure. This is AKS, and you can deploy this into Kubernetes in Azure, and here you can also, scale out. So if
right.
But
so is there any, if someone goes and looks at this and they've got some pretty detail-oriented questions, where would they ask these, and with the hope of kind of getting a reply?
Yeah, sure. So that's a great question. So first of all, if you have any issue about when you're trying the examples or the reference application, you can go here and create an issue. And
people are doing that.
We are monitoring this and answering and solving everything as much as we can. That's one thing. The other thing is, if you have a specific question, you can also send a question to, in most of the pages here, you can see this in list email, eShop feedback, and
Excellent.
you can send an email as well.
Okay. Well, thanks, Cesar. This has been excellent.
Cool. Thank you.
I know that there's a ton of folks that really appreciate this content. I know you spend gargantuan amount of time on this, 40 hours a week, right? Probably a few more than that. Okay, well, thanks
Thank you.
Yeah, thanks for listening to another episode of the On.NET Show. And today we learned about microservices and architectural patterns.